Hi, now we are going to talk about the closures. So what the closures is? So in general, closures is a function object which stores the variables or a free variables referenced in a different scope of the function, right? To understand the concepts, let's understand these things. So here we'll see that how every cell is created, right? And it has indirect reference for the variables in a multiple scope. For example, can say that here we are getting a function called outer. This is a local variable that we have created. Then in the inner function, we are again executing the same local variable over here, right? Now let's try to run this. When I run this, and then when I created, and then when I execute this outer function, because this outer function return the inner function now, right? Again, remember that we are not executing the inner function, but we are returning the inner function, right? But outer function has a variable x, right? And inner function has a variable x again. So if I run this, then when we check the code, so this is how we see the free variables like code.co.freeVars. This will give me the free variables. So the free variables in this code, we have x, one free variables, right? So as we can see, x is a free variables in the closures now. So if we'll see fn dot closures, we'll see that we have the cell at this address, and this cell is referencing to the string object at this address. So this string object has a value, and that value is stored at that address, right? So here we can see that free variable x is a reference to a cell object. This is the cell object we have, and then this cell object is again referencing to the string object, which is the value, right? Let's see the memory address of x in the outer function and in the inner function both, right? But again, we know that string is the intern object, right? So string is the, I'll say that so the memory address of the string is automatically being stored in a Python. So here we'll use something different object like list, where memory address can change, it's dynamic, right? So list is not intern. So here again, if you want to know about the intern, please check out the earlier video, right? So here we are again creating the outer function. The x is a list. We are trying to check the id. Again, in the inner functional also, we are also trying to check the same x variable id so that we know whether this x is the same x or not, right? And then we are printing the x value over here. Let's run this here. When we execute the outer function, right, this id has been created. So this is the outer id f9b40. When we check the closures, again this is a cell object referencing to this list object. Again, we know that this outer function has just executed, but still we have the another function over here too. For that, if we need to call this fn function, so that inner function will execute. If I run this, we're again seeing the inner id, which is this one, right? And then we can see that this id matches to the same id and the value we are printing. So we can see that the memory address of this x in the inner function and the outer function both are pointing to the same object, right? Now we can also modify the free variable. Like we know that we can modify the non-local keyword, right? Here we have this counter, which is a local variable. Then again we have this int, and then we have this another function. Then we have this non-local. We are referencing to this non-local variables, right? So this variable will be a non-local variable over here. Then we are executing the count value. So we are changing the count variable and then we are returning the value. And when we run this, and we see C is counter, that means counter function has executed, right? But inner function, inc function has not executed, so the count value is 0. Now when we see when we execute the C, we'll get 1. When we again execute the C, we'll 2. That means we are changing the same count value, right? We can also set the scopes, right? Here we are seeing that here in the outer function, we can see that we have this count equal to 0 as a local variable, and then we have this two function inc1 and inc2, both are referencing to the same object count. So here this look non-local and then non-local count, this object and this object is pointing towards the same object, and then we are increasing the value over here, and then this outer function is returning this both function over here. Let's run this. We are, because it is returning both functions, so we are storing the both function over here. And when let's check the closures for both the closure, we can see that here we have, because we have run the same cell, right? So both codes are the same cell, so the reference for both code are like, so the cell reference is same over here, right? And the object is also the same because we are again pointing toward the same count variable, right? So we are pointing to the same cell, or we are pointing to the same value. When we execute fn1, it is 1 because the count has increased. When we execute fn1 again, it is 2. But when we execute fn2, because this because the variable in function 2 is pointing to the same value, so now the count value is 2. When we execute this code, we'll get 3 as an output, right? Now the multiple instances of closures. So as we know that here, when we execute the function, every time the new ID will be created. The every time like a new variable scope has been created, right? So let's execute, let's run the function. Here we are creating executing the function 1, like the same function. Again we are executing the same function. Every time we can see that the ID this and this is totally different, because every time when you execute the function, right, a new local variable has been created, right? And then because new local variable is created, it is pointing to the same memory address. Same thing happens with the closer. They have their own extended scopes every time the closer is created. So every time when we create a closures, like, or like in, like, so every time when we create a variables, right, it will create a closures, right? And it will also behave the same way as we have seen over here. So here we have this power function, n is the variable. Again, this is also a local variable over here. Then we have the inner function, which takes x. X is a local to inner and n is local to power. We know that, and then this is returning x to the power n. So whatever the n value will pass, this will come over here, and then it will wait for the x variable over here. It will return inner function. So here n is the free variable over here. So we have a closure that contains inner and n variables both. So let's run this. When we say square is power 2, so it's like we have created the square function which takes 2 as a power value, as this value, but x is still we need to pass. When we see square of 5, we'll get 25. We can same way we can create cubes, and we can see that cell used for free variable in both cases are different, right? Here we can check that which cell we have used. Here the cell is different over here also and over here also, right? And it is creating a different object over here as well and over here as well, right? We can even check the ID. The both ID is totally different now. Again, let's understand this example. So consider that here we have the adder function which takes n, we have the inner function which takes x, then we are returning x plus n, which returns the adder function returns inner. Again here we have, because we need the value of n to execute the inner function, right? So here we have said adder 1 2 3 4. Every time we have created in a, we have stored in a new variables. And now let's try to run a adder 10 10 10 10. So every time we are passing the x value as 10, right? And then we are getting 11 12 13 14, because every time the n value was different. But suppose if you do this, here we have create function, create address, create adders. Then again we have this another variable adders is a list. We have the loop and value is changing every time. And then we are appending a lambda function every time into the adder functions. So every time we are saying there's lambda x, x plus n. So every time, so again this x value will be same every time, like whenever you call this function, every time you need to pass the x value. But here when we create this function, every time the n values should be different, right? Every time, for like first time n value is 1, then the 2, then the 3, then the 4, right? And then we return the adders. So here we are returning this list of functions. Let's see, here we have created this, here we have executed this create adder, right? Now in adders we have the list of functions, four functions we have, four lambda functions we have, right? When we see adder 3, that means this function 0 1 2 3, so last function. And then because we are because we are accessing the function, we need to pass the value of x, we are passing the 10, so we are getting the 14 over here. Let's use this adder 0, this function. So here the 0, in the 0 lambda function, the value of n should be 1, right? So when you add 10, it should be 11. But what happens over here, we are getting 14 now, we are not getting 11, so we are not getting the expected answer over here. In fact, when you do adder 0 1 2 3, for every time the n value will be 4 only, so every time we are getting 14. That means when the lambda are created their n, here when the lambda have created their n, so is the n used in the loop? So it's like, is the same n, like whenever we have created the lambda function, so the question is, does the same n, or like does the different n value is using? In reality it is using the same n value, because here n is not behaving like a local variable over here. It is not a local variable to this function, right? So this is what happens. We can check the here we can check that value. So here we are seeing that the free variables, so here n is the free variables, right? Here n is the free variables, right? And we are not storing these free variables over here, so we can check that we have the n. We can again check the closures. Here what we see is, every time we can see that, so it is referencing to the same object. In the every function, the n value is referencing to the same object. That means every time this, like this free variable is referencing to the same value, that is 4, because we only have one free variable, and at the last time it was referenced to 4 value, right, in the loop. Okay, now what we can see is, because we have seen that this n value holds the 4 value, right? So here we have seen that this n value, the value of n is 4 now, and because 4 is immutable object, right, it is also behave like an intern. right? So the memory address will be same. Here we can check that this address and this address will be same, and all the addresses are same, right? Because this 4 is the singleton object, right? You can, to create that, what you can do is you can store that free variable to a local variables, right? And that will work. Like over here we can see that what, so this is the same function, but here what we have created one variable called called step, and the value of step is n. Now when we do this, now this n is no longer a free variable now, right? So n value has been stored into the step every time. When we run this and when we check this closures, what we are seeing, and when we check the this free variables, we are seeing nothing. So there is no free variables now, because that variable's value has been stored in a variable called step, right? And now we can use this, and now we can use this each functions over here. We can use this because every time the value of n is different, and then we'll get the expected result, right? So this is what the closure is. So it store the free variables or the object of the functions, right? Thank you very much.